Imagine this: we nearly lost our chance to explore the moon. Not the moon itself, but our ambition to reach it. Picture the year 1969, the space race at its zenith. Apollo 11 had just achieved the unimaginable. Neil Armstrong's iconic words resonated worldwide. The world held its breath, anticipating America's next monumental step. Then came Apollo 12. Apollo 12 wasn't merely about another flag or more lunar rocks. It was about demonstrating that humanity had a place in the cosmos. Yet, like all missions, it was laden with peril. Their journey was destined to be anything but routine. The world held its breath as Apollo 12 ascended into the heavens. The engine's roar echoed across the Florida coast. It was November 14, 1969, a mere 4 months after Apollo 11's historic landing. Apollo 12 was not just another mission. It symbolized human perseverance and grit. The mission patch, crafted by the crew, featured a sailing ship embodying the spirit of exploration and discovery, journeying towards the moon. The ship bore the names of the 3 astronauts, their fates intertwined with the mission's success. Apollo 12 embarked on its voyage, carrying the hopes and dreams of an entire nation. The world watched in awe as the second American flag was ready to be planted on the lunar surface. The stage was set for an unparalleled adventure. Apollo 12 wasn't just about reaching the moon. It was about landing in a specific spot. Imagine aiming for a bullseye, but your target is 240,000 miles away. Apollo 11 landed almost 4 miles off target. This time, NASA wanted precision. Apollo 12 aimed to explore the ocean of storms. Scientists believed it could reveal clues about the moon's formation and its relationship to Earth. More importantly, Apollo 12 was tasked with retrieving parts from Surveyor 3, an unmanned probe that landed on the moon in 1967. Analyzing these parts after years on the lunar surface would provide valuable data. Landing near Surveyor 3 required incredible accuracy. Their mission, a delicate dance between human skill and technological prowess. At the helm of this daring mission was Commander Pete Conrad, a veteran astronaut celebrated for his wit and composure under pressure. Accompanying him was lunar module pilot Alan Bean, a skilled pilot and engineer. Bean's critical role involved piloting the lunar module, the Intrepid, during its descent and ascent from the moon's surface. Rounding out the crew was Command Module pilot Richard Gordon, an experienced astronaut from Gemini 11. Gordon's task was to stay in lunar orbit aboard the command module, Yankee Clipper. Together, Conrad, Bean, and Gordon made a formidable team. They underwent rigorous training, pushing their physical and mental limits. Their camaraderie and shared mission would be put to the test in the vastness of space. The challenges they faced would forge an unbreakable bond of brotherhood. Apollo 12 was not just about the astronauts, it was about teamwork on an epic scale. Thousands of engineers, technicians, and scientists worked tirelessly behind the scenes. From designing the powerful Saturn V rocket to crafting the delicate lunar module, every piece was a marvel of human ingenuity. The command module, the astronaut's sanctuary for most of the mission, showcased advanced engineering. The lunar module, built for the moon's surface, was a feat of lightweight design and robust propulsion. But the mission's success wasn't just about the hardware. It was also about the software, the communication protocols, and the meticulous flight plans. Every aspect, no matter how minute, was examined and perfected. Apollo 12 was a symphony of systems, a testament to the power of human collaboration. November 14, 1969. The world watched. a mix of excitement and anticipation in the air. Apollo 12, a towering symbol of human aspiration, roared to life. The Saturn V rocket propelled Conrad, Bean, and Gordon skyward. Just 36 seconds into the flight, the unexpected happened. A blinding flash, a jolt that reverberated through the entire spacecraft. Alarms blared inside the command module. Lightning. The mighty Saturn V had been struck by lightning, twice. The electrical surge wreaked havoc with its delicate systems. The fate of Apollo 12 hung precariously in the balance. Each second stretched into an eternity as Mission Control raced to understand the extent of the damage. Despite the intermittent communication, contact with the spacecraft was maintained. The incoming data revealed a dire situation. The electrical system of the spacecraft had suffered significant damage. The entire world watched, both fascinated and horrified. Inside the command module, Conrad, Bean, and Gordon worked tirelessly. Their rigorous training took over in the midst of the turmoil. Engineers on the ground worked frantically to devise a solution. Failure was simply not an option. Amidst the turmoil, a young engineer named John Aaron had a breakthrough. Remembering an obscure switch, the SCE to AUX, he conveyed a crucial instruction to Mission Control Flight: try SCE to AUX. The directive was transmitted to the spacecraft. Bean found the obscure switch and activated the SCE to AUX. The alarm stopped, voltage readings normalized, the fuel cells buzzed with renewed power. The spacecraft was pulled back from the edge. Apollo 12, defying the odds, was back on course. The near disaster during launch only fueled Apollo 12's determination. Conrad, Bean, and Gordon pressed on with a renewed sense of mission. 4 days post-launch, the Intrepid, with Conrad and Bean aboard, detached from the Yankee Clipper and began its descent to the moon. Conrad expertly navigated the Intrepid through its final approach. The lunar surface grew closer with each passing moment. With a soft landing, the Intrepid settled on the ocean of storms. "Houston, Intrepid. We are on the plain at Surveyor Crater," Conrad reported. Their destination, Surveyor 3, a mere 600 feet away. Apollo 12 had executed a precise landing. After a meticulous inspection of the lunar module, Conrad, with Bean close behind, descended the ladder and made their first steps on the lunar surface. The date was November 19, 1969. Conrad, known for his humor, couldn't help but make a light-hearted comment about Neil Armstrong's iconic words. They firmly planted the American flag into the lunar soil. The flag, supported by a wire frame, appeared to flutter as if in a breeze. The lunar terrain was stark, barren, and unforgiving. For Conrad and Bean, it was an open field for scientific exploration. They moved with a clumsy elegance, their spacesuits restricting their movements. Yet, their enthusiasm far outweighed any physical challenges. Their primary target, Surveyor 3. The probe stood as a relic from a previous mission. Conrad and Bean approached it with a blend of awe and scientific interest. They meticulously documented the probe's state. Samples of its materials were collected for further study on Earth. The Surveyor's television camera drew significant attention. Conrad removed the camera with great care. The Surveyor, a silent observer, seemed to watch their every move. They sought answers and departed with a wealth of knowledge. Apollo 12's mission extended beyond just planting a flag and retrieving Surveyor 3. It was a mission deeply rooted in scientific exploration. The mission included a collection of scientific instruments, essentially a compact laboratory aimed at uncovering the moon's mysteries. This compact laboratory, known as the Apollo Lunar Surface Experiments Package, or ALSEP, marked a major advancement in lunar research. Conrad and Bean deployed the ALSEP, which was powered by a nuclear generator. This power source enabled the instruments to function for years, continuously transmitting data back to Earth. One of the instruments was a seismometer, designed to monitor moonquakes. Another crucial instrument was the solar wind spectrometer. Data from this spectrometer would provide insights into how the solar wind interacts with the lunar surface. The ALSEP featured a lunar dust detector. This instrument tracked the buildup of lunar dust, a critical issue for future explorations. Additionally, the Lunar Atmospheric Composition Experiment sought to study the Moon's sparse atmosphere. The ALSEP data would be a treasure trove for lunar researchers. It would enable them to enhance their understanding of the Moon's internal structure. Conrad and Bean gathered a variety of lunar samples, showcasing the geological diversity of their landing site. Once back on Earth, these samples were meticulously examined by scientists in labs worldwide. The ancient secrets of the Moon were gradually being revealed. The Apollo 12 mission marked a significant achievement in human curiosity and scientific exploration. The ocean of storms, once thought to be barren, turned out to be a repository of geological marvels. The samples collected included basalts and breccias, volcanic rocks, and rocks fused by impacts. These rocks chronicled the Moon's tumultuous history, shaped by volcanic activity and meteorite collisions. By analyzing these samples, scientists ascertained their age and the genesis of the ocean of storms. Lunar dust unveiled secrets, narrating a complex tale. Tiny glass spherules and rare minerals provided clues about the Moon's internal processes. Each sample was a piece of the puzzle, offering insights into the Moon's origin and evolution. The treasures of the ocean of storms, brought back by Apollo 12, transformed our understanding of lunar geology and inspired a new generation of scientists. With their mission accomplished, Conrad and Bean prepared to leave the ocean of storms. They left behind instruments that would continue to unveil the Moon's mysteries. The Intrepid, filled with precious lunar samples, was ready for the journey home. After a thorough check, they ascended to reunite with Gordon. Gordon welcomed them back with joy and relief. As they splashed down in the Pacific, they knew their lives had been profoundly altered. Section 2. Lessons Etched in Stardust. Apollo 12, often overshadowed by Apollo 11, marked a pivotal moment in space exploration. It confirmed that landing on the Moon was not a one-time event, but a repeatable feat, allowing for detailed scientific experiments. The mission's triumph, despite the harrowing lightning strike, underscored the robustness of the spacecraft and the crew's training. The precise landing near Surveyor 3 highlighted NASA's advancing expertise in lunar navigation. This mission enabled the collection of diverse geological samples, providing scientists with material from a known and varied location. These samples were crucial for understanding the Moon's composition and geological history. The ALSEP experiments, powered by a nuclear generator, sent valuable data back to Earth long after the mission ended. This ongoing data flow offered new insights into the Moon's internal structure, seismic activity, and its interaction with the solar wind. The information gathered transformed our perception of the Moon, revealing it as a dynamic world with a rich and complex history. Section 3. The Blueprint for Exploration. Apollo 12 was more than a lunar mission. It laid the groundwork for future space endeavors. The insights gained and technologies created influenced subsequent space missions. Its scientific objectives paved the way for future lunar explorations. Navigation techniques and sample collection methods were crucial for future planetary missions. Apollo 12 inspired a global audience, demonstrating humanity's potential. It fostered a sense of wonder and belief in boundless possibilities. Apollo 12 remains a symbol of human ambition and our quest to explore the unknown. A legacy, written in moon dust. Over 50 years have passed since Apollo 12 landed on the ocean of storms. The impact of that mission still echoes today. It's a legacy inscribed in moon dust, woven into the fabric of human history. Apollo 12 stands as a symbol of human ingenuity and bravery. The near catastrophe at launch turned into a victory of problem solving. The mission's scientific findings revolutionized our knowledge of the moon. The moon emerged as a tangible world, ready for exploration. The enduring legacy lies in the spirit of exploration it sparked. The undying embers of exploration. Apollo 12 demonstrated that humanity can achieve the extraordinary when united in purpose. It brought people together worldwide, showing that our differences are insignificant compared to the vast expanse of the universe. The mission's legacy endures in the many scientists, engineers, and astronauts who were inspired by those historic moments. It sparked a fervor for discovery, driving innovation and expanding the frontiers of human exploration. As we now prepare for lunar bases and missions to Mars, we carry forward the lessons learned from Apollo 12. The enduring spirit of daring and belief in human potential are the lasting embers of exploration.